Guys, later on I'm going to discuss some information about mechanical energy, but first I'm going to speak about some physical quantities and some prerequisites. So in mathematics, if we have a function f of x equal to 3x squared plus 2, this is the independent variable and this is the dependent variable. Then the derivative of f of x with respect to x is going to be equal 6x plus 0, because 2 is a constant and the derivative of a constant is equal to 0. Then also x prime is going to be equal to 1, because d by dx for x is equal to 1, because the variation of x with respect to x is equal to 1. But in physics, this is not the case. In physics, instead of dx we have dt, because all the physical quantities are measured with respect to time variation. Then dx by dt will not equal to 1. Dx by dt is going to be equal to v, which is the ratio of displacement x over over delta time dt. So v is going to be equal v meters per second. Then if we make the second order derivative with respect to time for x, will give us a, which is meters per second squared. Then dx by dt gives v, which is measured in meters per second in SI unit, and the double derivative with respect to time for the value x with respect to time is going to be equal a, which is the acceleration of the body, which is measured in meters per second squared. Another prerequisite: if we have a circumference, this is a circle and this is its center. If we make this figure, then this curvature is called S. S is the curvilinear abscissa, and S is equal to the radius of curvature multiplied by the angle theta. Then this measured in meter, and this is in radians, and this in meters. So if we make the derivative of the value s, we will get v r theta prime. R is kept the same because it is invariant, because it's a constant. So then we have v is equal to r theta prime, where theta prime is the angular speed. Also, if we make the second order derivative for s, so it means that we are making the second derivative of s, it will be equal to r theta double prime, and this is the angular acceleration. So then v equal to r theta prime and a equal to r theta double prime. Now I'm going to speak about work energy theorem. And the work energy theorem, where does it come from? First, if we have a moving object with acceleration a different from 0, then we have to use the rule which states that v final square minus v initial square is equal to 2 multiplied by the acceleration and the distance covered by the object. So if we multiply both sides of this equation by half, then we get what follows. We get half v final square minus half v initial square equal to half multiplied by 2a multiplied by d. Then 2 down here will cancel the 2 up right there, and we end up the following equation: half v final square minus half v initial square equals to A and D. Then if we multiply this equation by the mass of the object on both sides times mass, we end up with half mv final squared minus half mv initial squared is going to be equal mad. And this term is not weird, because as we all know, Newton's second law says that sigma f external is equal to ma. Then this quantity will be the summation of the external forces acting on the object of mass m. So therefore, half mv final squared minus half mv initial squared is going to be equal sigma f external multiplied by d. But also this term is not weird, because as we know, work is equal to F dot D, which is the work done by the force F. Therefore, the work energy theorem is proved: half mv final squared minus half mv initial squared is equal to sigma work done by F external. And this is the delta kinetic energy theorem, which is equal to sigma work done by F external, which means that the summation of the forces and their work acting on the object of mass m. So therefore, these are some prerequisites. As we said before, this is dx by dt, the double derivative with respect to time for x, we got a, and this is the r theta, and we get into r theta double prime, r theta prime, and this is we end up for work energy theorem, which states that the delta kinetic energy is equal to sigma work done by F external. It means that Ke final minus Ke initial for the object is equal to sigma work done by F external. Thank you, and hope that you all got benefit from this short video.